Interpolation methods, linear interpolation and nearest neighbor interpolation under the guidance of Dr. Dipti Patil. In this presentation, we will understand what interpolation is, why it is important, how it works mathematically, and how it plays a crucial role in the data science pipeline. Why do we need interpolation? In data science, we often deal with missing or incomplete data. Sometimes values are not recorded. Sometimes sensors fail. Sometimes data points are collected at irregular intervals. For example, imagine measuring temperature every hour, but one reading is missing, or tracking stock prices, but data for a particular minute is unavailable. In such cases, instead of discarding the entire data set, we estimate the missing values. To solve this problem, we use interpolation. Interpolation helps us estimate unknown values between known data points. It allows us to maintain continuity and improve data quality. What is interpolation? Interpolation is a mathematical method. It estimates values within a known range of data points. If we know two data points, we can predict the value between them. The key idea is that the unknown value lies somewhere between the two known values. There are many types of interpolation methods, but today we will focus on two important ones: linear interpolation and nearest neighbor interpolation. Linear interpolation. Linear interpolation assumes a straight line relationship between two known points. It connects two known points using a straight line. Then it estimates the intermediate value along the straight line. This method works well when data changes gradually and smoothly. Formula of linear interpolation. The formula is y equals to y1 plus x minus x1 divided by x2 minus x1 into y2 minus y1, where x1 and y1 are the first known point, x2 and y2 are the second known point, x is the value where we want to estimate y. This formula calculates how far x is between x1 and x2, then applies the same proportion to y. This method gives smooth and continuous results. Solve example of linear interpolation. Let us take 2 points. Point 1 2, 4. Point 2 6, 12. We want to find the value at x equals to 4. Step 1. Identify known values. x1 equal to 2, y1 equal to 4, x2 equal to 6, y2 equals to 12, x equal to 4. Step 2. Apply the formula. Y equals to 4 plus 4 minus 2 divided by 6 minus 2 into 12 minus 4. Y equals to 4 plus 2 divided by 4 into 8. Y equals to 4 plus 0.5 into 8. Y equals to 4 plus 4. Y equals to 8. So the interpolated value at x equal to 4 is 8. This shows that the value increases proportionally between the two known points. Nearest neighbor interpolation. Now let us understand nearest neighbor interpolation. Nearest neighbor interpolation is very simple. It does not calculate slope. It does not use any mathematical formula like linear interpolation. Instead, it assigns the value of the closest data point. It simply checks which known value is nearest to the required x value. For x equals to 4, distance from 2 is 2. Distance from 6 is 2. If the distance is equal, we select one based on predefined rule. So the value becomes 4. This method creates step-like results instead of smooth curves. It is fast and computationally simple. Comparison between two methods. Linear interpolation produces smooth results, more accurate for gradual changes, uses a mathematical formula. Nearest neighbor interpolation produces step-like results, faster and simpler, no slope calculation. So the choice depends on the type of data and application. Role in data science pipeline. Now let us understand how interpolation fits into the data science pipeline. A typical data science pipeline consists of the following stages: data collection, data cleaning, data preprocessing, model training, evaluation. Data collection. Data collection is the process of gathering raw data from various sources relevant to the problem. These data may come from sensors, databases, APIs, surveys, or web scraping. At this stage, data may be incomplete or irregular. Data cleaning. Data cleaning involves removing errors, duplicates, handling missing values or inconsistent data. This is where interpolation becomes important. If some values are missing, instead of deleting rows, we estimate them using interpolation. This improves data consistency. Data preprocessing. Data preprocessing transforms data into a structured and suitable format for modeling. This may include normalization, scaling, encoding categorical variables, and filling missing values. Interpolation helps ensure that no gaps remain in the dataset. Without proper preprocessing, models may perform poorly. Model training. Model training involves feeding processed data into a machine learning algorithm to learn patterns. If data contains gaps or irregularities, the model may learn incorrect patterns. Interpolation ensures smoother and more reliable training data. Evaluation. Evaluation measures the model's performance using appropriate metrics to assess accuracy and effectiveness. If preprocessing was done properly, including interpolation, the evaluation results are more reliable. Data cleaning and preprocessing stage in detail. Interpolation is mainly used during the data cleaning and preprocessing stages. It plays a very important role in improving dataset quality. It helps in handling missing values in the dataset. It helps in filling time series gaps when data points are missing at certain timestamps. It is also used in resampling data, especially when we need to adjust data to a new frequency. In addition, interpolation is widely used in image resizing tasks. For example, if sensor data has missing timestamps, linear interpolation can be used to estimate and fill those missing values smoothly. Similarly, in image processing, nearest neighbor interpolation is commonly used to resize images quickly by assigning the value of the nearest pixel. This ensures that dataset remains complete, consistent, and suitable for model training. Applications of interpolation. Interpolation is widely used in many domains: time series data analysis, sensor data completion, stock market analysis, image resizing, signal reconstruction. In image processing, nearest neighbor interpolation is commonly used for resizing images because it is fast. In time series forecasting, linear interpolation is preferred because it provides smoother transition between data points. In weather prediction, missing temperature values are often interpolated. In healthcare monitoring, missing patient data may be estimated. Advantages and limitations of interpolation. Before we conclude, let us briefly understand the advantages and limitations of interpolation methods. One major advantage of interpolation is that it allows us to preserve valuable data instead of deleting incomplete records. It improves dataset continuity and helps maintain patterns within the data. Linear interpolation is especially useful when the data changes gradually and follows a smooth trend. Nearest neighbor interpolation is extremely fast and computationally efficient, especially in image processing tasks. However, interpolation also has limitations. If the missing gap is very large, interpolation may not give accurate results. It assumes that the pattern between known data points continues smoothly, which may not always be true. In highly fluctuating or unpredictable data, interpolation can introduce estimation errors. Therefore, selecting the correct interpolation methods depends on the nature of the dataset and the problem we are solving. Understanding when and how to apply interpolation is an important skill in data science. Conclusion. Interpolation is a powerful mathematical tool used to estimate unknown values between known data points. It plays an important role in handling missing data and improving dataset quality. Linear interpolation provides smooth and proportional estimation. Nearest neighbor interpolation provides fast and simple approximation. Both methods are essential in data science, especially during the data cleaning and pre-processing stages of the pipeline. Understanding this method helps build better and more accurate machine learning models. Thank you.